Another word that you need to learn in this unit is overriding. What we're doing here, there in the superclass, in the bug class, there is an act method, a public void act method. Since we are writing a public void act method in the rainbow bug, what we are doing is we are choosing not to inherit bug's act method, we are writing our own. So we say that we are overriding the act method in bug. Now, frequently, maybe even usually, when you override a method from the superclass, you will frequently call that method that you are overriding in your definition. So yes, we are overriding the act method. We're completely redefining it, except that in the very first line we're calling it so that we get all that code for free, and then we just add a few lines of code on top of that. So overriding a method is a big deal in inheritance. In GridWorld, GridWorld is designed to call the act method on every actor that it contains every time you click the step button. So the idea is this is just a GridWorld thing, not an inheritance thing, but when you run a GridWorld program, the idea is when you hit step, every actor in the grid is having its act method called, right? If I create a new, just ordinary bug there, if I hit step, the act method was called on this bug, and this rock. When I hit step again, act, right? It is looping through all of the actors in the grid and calling the act method. So the act method is the most important method in GridWorld. It's where you define all of the behaviors for the thing that grid contains. Rock, as you can see, if I click on it, you see I can call the act method on rock. So it has an act method, but that method is completely empty. There is nothing inside of it. Also notice when I click on rock, there are a lot of methods that are the same here, whereas if I clicked on bug, right? If I click on rock, you'll see there's a get color, get direction, get grid, get location, move to, put self in grid, remove self from grid, set color, set direction, and toString. All of these methods are methods that the rock has. If I click on a regular bug, all those methods exist as well. Get color, get direction, get grid, get location, move to. In fact, these are the exact same colors that were available in rock. The truth is that both bug and rock extend the actor class. And so they get all of the actor code for free. And all of these methods are actually just actor methods. And the idea is the actor class just contains code that allows things to exist in GridWorld. So in order to be in GridWorld, you need to have a get color, get direction. You need to have all these methods available to you. So inheritance allowed the people who wrote GridWorld to put all that code in one place and then put specific code for specific kind of actors in the other classes. So rock extends actor and gets all this for free and then has not much else in it. Bug extends actor, gets all this code for free, and then plus adds a few other methods like turn, so that it always turns 45 degrees to the right. It moves forward when it can. It turns when it can't, and it makes itself always red. Rock always makes itself black. Or if I pick another black rock right there. These classes all extend actor. It shows you how powerful inheritance is, right? You put all this code in one place, you test it rigorously, you make sure it works, and then it can be applied to all kinds of different other classes that you'll include. And we're going to study lots of other different kinds of things we put in here. We're going to make all kinds of bugs, we're going to make all kinds of critters, and take advantage of inheritance quite a bit.